Okay, so now we have a window, right? We can click, we can run, we have a window, but we don't have anything else, right? So now the next thing is to draw something on the window, right? And it is simple, not so simple, but so first of all, okay, my bad. First of all, we need OpenGL context, right? So how to open or create OpenGL context? So we can just search OpenGL context in Windows. Right? Every operating system has its own way of creating OpenGL context, and we are gonna go through the documentation, and here we find it. So first of all, we have to fill in this struct, right? Yep, it's a big struct, but yeah, we have to do what we have to do, right? So we'll call a function called initialize OpenGL, right? And this would be uh, method function procedure. What the hell, right? And uh, we'll call this once we have something run, right? So we can only initialize OpenGL context once we have our window up and running, right? So we'll do initialize OpenGL. Okay, let's go. So we need all these things, right? So we'll just create a pixel format descriptor, which is win32, copy paste this guy here, right? And then we'll initialize. We can also search for this guy. Not there, not there. My bad. That's so bad. Yeah, so this is the struct. We can go into the detail of what it does, but who cares? We want OpenGL, not so it's a size. So we just need to do this like this. So we get the size of that, and then we have a version. Version, it has to be one. Like it's a necessary thing to do. Yeah, that's it. Nothing else. And then we have to define this particular fellas. We have to do here and version like this, and then we have dw flags, which are this ones, and we have to do like this win32, win32. Yeah, I'm just, yep, win32. dw flags, then there is I pixel type. So I pixel type, so what type of pixel we need for OpenGL? So it's a this RGBA, right? So our pixel would be so our pixel would be, wait, yeah, our pixel would be 4 byte, 1 byte for red, 1 byte for green, 1 byte for blue, 1 byte for alpha. So it's RGBA. And then color depth of the frame buffer, so it's a color bits. So as I told you, the color bits would be 32 bits because it's a 4 byte for 1 pixel. So that means 1 byte is 8 bits. So there's a 32 bits for one color. Red bits, this is all we don't care. We care about C depth bits, and depth bit would be for depth buffer, which is 24. Then we care about stencil buffer. We are not gonna use depth buffer stencil buffer for now for any purposes, but yeah. Then we need this I layer type, which would be win32 dot pft main plane. This is, I guess, deprecated, something like that, but whatever. I guess we don't even need this for now. Yeah, we don't need that. Okay, so now there are a couple of steps which will go above your head. So now what we need to do is to do very complicated thing. Not complicated, but yeah. So now what we need to do is we need to choose a pixel format, right? So whatever we define here was our pixel format descriptor. This is what we need. We might not get what we defined here. We pass this into something called choose pixel format, and then it takes in this specification and it checks if current OpenGL context is supportable or not, and whatever it can allow us to do, and then it will, yeah. But most of the time these values will apply. So it will do, we do choose pixel format, so we get this pixel format, and now we set that particular pixel format. Once we set this pixel format, we have to create a context, which this is OpenGL context. Then we have to make our context a current context, and that's it. Then our OpenGL context is set. But for that we need a device context, right? So as we told, every uh, every window has its own device context, and that's what we need. So there is a function called get device context, get dc, and we need that. So basically what we'll do is we'll pass in device context, right? So basically we'll pass in this device context, right? And we'll define this device context after we get the handle. So we can just do device context is equal to win32 dot get. My god, what am I doing? And then we have to pass this handle. My bad. Right. Oh, this way you get this device context, and there is a reason why we are not releasing. So there is a we have to release this context. Like once we use this context, we have to release it, because the same device context might be used for my other windows for my application. But we have defined here that my window has only one DC and unique DC. So if I create one more window for something which I want to do, which we will never do in our game, so it will also have its own device context. But I can also have one device context which is shared between three windows which I have created. But we don't need those complicated. So it's like it's for us. We if we don't release it, it does not matter. Okay, so now we got device context. We can pass in device context in OpenGL here. So we can just do device context, which is a type of HTC. This is a yeah, it's a handle to device context. Stupid naming convention Microsoft has. Yeah, capital letters. Okay, so now we have to call this function. What is this? Yeah, so basically we can now have pixel format, right? So pixel format, which is choose pixel format function. So we can choose pixel format. It takes in device context, right? And it takes in our pixel format descriptor, and then it gives us something pixel formatty back. 1 second, let me turn off my AC. Okay. Uh, so now we have to set pixel format. So win32 set pixel format, and it takes device context, uh, device, what am I doing? Yes, device context and pixel format. Dude, I have a habit of Pascal casing. Yeah, because I still code for Unity in C#, so that Pascal is still there. and we have to pass this pixel format descriptor, and now we can call this OpenGL rendering context, right? So now we can have like uh, GL context, and we can call pin32 WGL create context, and we have to pass our device context, right? And then we have to make WGL make current, which takes in device context and GL context. So it all compiles nice and easy. So now it's done. Now we are done. We have initialized OpenGL here, and what we can do is this function can fail, right? So if we go my bad. uh, so if we go into this function can definitely fail, and we might have to handle this fail. So it takes choose pixel format. We can just copy, we can just search for mstn. So it says it returns integer. Okay, if function succeeds, the return value is pixel format index 1 base that is closest match to the given pixel format description. So yeah, that's what I said, like closest match for pixel format descriptor. It is not exactly what we define, it is what we get, whatever is supported. If the function fails, return value 0, right? So there is a return value 0. So what we can check here is this function can return bool, not can return, will return bool. And so here we can check if pixel format returns value 0. So if it's 0, then we'll return false, right? And the function, yeah, and that's it. So if we go further, we do set pixel format, and I think it's the same for this one also. We can go to the mstn set pixel format, so it returns boolean. So this is nice. So if the function succeeds, returns true, otherwise false. So we can just do if set pixel format. So if this happens, that is fine, otherwise yeah. And all these things we can just take in here. So else we can just do return false, and here we can do return true. This can also fail, so wait for those cases. Now we can check for WGL context, same thing, check what it does. So it returns HGRR, yeah, so it just returns this, but this can also be null, I guess. So return value, if the function succeeds, return value is valid handle. It is yeah. So if GL context is not nil, then we do this, else we just do return false, right? So GL context, if it's not nil, then we do this, otherwise we just return false. WGL make current, this can, I guess, also fail. Yeah, window, when you do platform, yeah, it returns bool return value. When the function succeeds, the return value is true. Yeah, so here we also can put this in if, and if this is we don't have to do that, we can just return this at the end, right? So return this. So there is no error. Okay, there is error. Cannot assign bin32 make current of type bool to bool. Okay, because don't ask me, man. Don't ask me. We have to pass that. Okay. So now, if we fail init OpenGL, it returns if init OpenGL like hmm, we've done that, but currently we don't need anything. If it fails, it fails. We don't care. Or we can just print something other than bool. Let's print also because sometimes it will be hard to debug. So choose wrong pixel format GL context creation tool. Yeah, this is fine. So initialize OpenGL, and now we can. Okay, one more thing we have to do. If we got this right, we can't just. Yeah, let's just do here. So if init OpenGL, then one more thing we have to do is we have to load OpenGL functions from the driver, or DLL, whatever, from the driver, I guess. Yes. Windows operating system does not give us those functions. We have to load them by ourselves. Fortunately, Odin language has that support by default. I guess there is a load to function. So if I go GL or open, my bad, OpenGL, there is a help for Odin. Okay, good shader source. These are all nice, but not what I'm looking for. There is OpenGL wrappers. I guess it's in README. Yeah, so in README there is a function called load up to, which is what we need, right? So this function, so we have to call load up to, and we can just look into this function, right? We can just search and look. So basically there are versions, and depending on what version we want to use for OpenGL, it will load, function from OpenGL 1 to that particular version. So what we are going to do, we are going to define GL major, which would be 4, and then GL minor, which would be 3, I guess, or 1. uh, let's use 4.3 version of OpenGL. And in the load function, load up to function, we can just pass in GL major version and GL minor version, and also we need to pass a set proc address method. So this method is what we said. This method is used for loading the function, right? So there are all these functions, but where we find this function and that particular logic is in this set proc address. Yeah, it's just loading functions, that's it. So we are loading functions from TLL. it. There was something called, let me do OpenGL. Set prod GL set prod address. So we can find that, and that is this function. So we can call this function. We pass this function into us like this, and now we can call our OpenGL functions. Right. Once we load up these functions, now OpenGL is initialized. So if we if we don't initialize OpenGL, right, what we want to do is we want to call OpenGL field initialization failed, and we don't want to do this. So all of this we want to do here, because there is no point, right? There is just no. Okay, I'm doing something weird. Wait, what the heck is this? Yeah, right. There is no point if our OpenGL for some reason does not work. There is no point on doing that. One sec. So now that is interesting. So once this loop get over, here we'll run our game code, right? So this is where we run our game logic and all these things, whatever we want to draw, stuff like this. So there is a function called clear. So there are multiple functions. Okay, now we are into the territory of OpenGL, right? We'll just do very normal thing, and then we'll end the stream here, and we'll continue the stream, and we'll create a very simple OpenGL renderer which can render 2D rectangles, and then we'll make a game using those 2D rectangles called a very famous game called Pong. So we just gonna create this Pong game, and once we get that game running, we'll create a new game, and each time we create a new game, step by step we are going to improve our game engine, our game renderer, everything with it will improve it step by step. Right. So what we are doing here is not, we are not making an engine, right? So we are not making engine, right? We are not doing that. We cannot, as a solo developer, we cannot compete with making engine with making an engine which is compared to Unreal, Unity, Godot, right? We are not competing with these guys. We are not at all. What we are doing, we are solo developers, or not solo developers per se, but small team. Let's say our goal is to make game. Right? There is no doubt about this. Our goal is not to make technology. Our goal is to make game, right? Not technology, which is part of it. I'm not denying it, but yeah. Also, we want to make a high quality game, right? We care about our quality, and we also don't want to waste our time, right? Don't want to waste time. What happens, it sounds contradictory, this waste time. It sounds very contradictory if you you know, we are making everything from scratch. If we use Unity, we'll definitely not waste time, right? That's the whole mindset. But I've used Unity quite a bit. I'm doing it professionally for quite a lot of years. Trust me, you waste a lot of time. Like for simple games, not necessarily. Uh, Actually, you don't waste time here, but sometimes the quality is not there, right? What do you mean by quality? Because they have lots of features, right? First of all, they have so many features. We don't need them. In what we are doing here, we are making game, and we are making it like caveman style. You'll understand what this means. Like it's a caveman style. What this caveman style means is that you don't over engineer anything. You just do what your game needs. Right? We have a game in mind, and we are making that game. Each and every technology that we are making, either it is collision detection, either it is like a rendering engine, either it is lightning, either it is font rendering, anything we are doing, we have a goal in mind that we want to make this game, and we'll create only stuff which is needed for that game, nothing more, nothing less. That's it. That is caveman style. We don't create abstraction. We don't get into this mindset that, oh, how do I organize my code, how do I write my function so that it is only 5 line of function, how do I write my no, 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 no. Those all things are just bullshit. It doesn't do anything, like doesn't do at all anything. What we care about is the final product, final quality of the product. That's why we'll do our memory management by ourselves. Because what does quality mean? The quality means it should run, our game should run on 60 frame per second on any machine. And if it's older, and if it's older than 30 fps for most of the game, like 30 fps is also like not acceptable right now. Like most of the hardware should run a game at 60 fps. It should have nice game feature. It should not be memory hog, right? Like it should not eat all of your memory. It should be small in size. How we can achieve all these things is we are making everything from scratch. Why? Because we are doing caveman style. We only do what is required. The less code, we have less code to run, we have less stuff to put in our game. It's easy. Like Unity, when Unity builds our game, we can try this on stream. So basically what we'll do is we'll create the same form game, right? Same game, nothing more. Same game we'll create in Unity. We'll build this Windows executable, right? We'll build executable, and we'll see the difference of RAM usage, right? How much RAM is usage by the same game, same functionality, and how much build size it is, right? These two things I care about, right? Because whenever somebody's download, I don't want to use their RAM as much as I need to, and stuff like this. And we'll just see how much difference does it make. Okay. Yeah, we went into some rabbit hole there, but yeah, no problem. Let's come here. So uh let's open. Okay, what we can do is so we can open OpenGL wrappers, right? So we can go to this wrapper. These are all the functions, right? These are all the functions which you need. First of all, we'll print what kind of graphics card we have, right? So for that we have a GL string, at GL string, get string, not GL string. Some people might hear G string, but that's not that's not what it is. Okay, that's not. Yeah. that is not what it is. Okay, get string, so we can call get string, and I guess we can call this version like this, GL version, and then we can print this, I guess. So if we run, okay, GI, okay, let's do this for now. So okay, so it prints now. Oh, we have 4.6 NVIDIA, right? So we have 4.6 version of OpenGL running. So we are using 4.3. We can also use 4.6, but we are using 4.3 OpenGL because we want to support some old hardware or something, and we can do something like that. So we can have still 4.0 also here. We can also go far back, but who cares, right? The current GPU I have, I think most of the gamers who want to play the game has that GPU, this GPU. Like it's not that like 4.3. We are supporting 4.3, so it's still older. Yeah, it's supported by some. Yeah. So now we can print a version. We can also do some things with this version if you want to do, but we don't care. uh, so we have clear color, right? So we have this clear color function. So this will set what kind of color we want to clear with, right? So what will define some color here. Our screen will be painted with this color or clear with this color. So we can pass in red, green, blue, alpha here. It's in 0 to 1 range. So let's do red, right? And alpha would be 1, otherwise it would be transparent. And then we can call GL clear. So GL clear will use this particular color that we have set for clearing our screen, but still this won't do anything. uh, GL clear has a mask. Okay, so GL clear has mask. We have to tell it to do color buffer fit, right? So what this does is it writes this color into this color buffer fit, right? And it still doesn't do anything. Why? Because I tell you, because when we define our OpenGL function, what we have support for is double buffer, right? So what is double buffering? So double buffering is a very cool concept. So basically we have a window, right? And what we have is array, a 2D array of pixels, right? And we write whatever. So GPU, when we do some GPU pipeline, when our everything goes to GPU pipeline, at the end of the GPU pipeline, what we get is array of pixel data, right? Which is colors, like what color is in this pixel, what color is in this pixel, that data. And this data goes to monitor using HDMI cables. Let's go. So HDMI cable goes from GPU to your monitor, and if your monitor is old, you might be using VGA cables, right? So so this data goes from GPU to HDMI monitor with HDMI cable. What used to happen earlier is that we used to write into this buffer and at the same time drawing in the screen, but eventually that led up to tearing up the screen and lots of other things. So now we have two buffers. So one is a buffer and double buffer. So that's what it means. We have two pixel buffers. We write into this one, and then we say that okay, now show this buffer, and now we write into this buffer. So we take a turn, right? We show one buffer, we write into another, then we show that buffer, we write into this. So every time we are writing to the buffer, this color buffer, pixel buffer, whatever you want to call it, uh, we are not showing it, right? So currently what we are doing is we are writing, right? So this particular function writes to our color buffer, writes to our pixel buffer, but we are not showing it, right? For showing it, each operating system has their own function, and for Windows it is swap buffers, I guess. Let me check. Swap buffers, yes. So it's a swap buffer, swap buffers, and it takes device context which you already have, and now it will show the red. Let's go. So now we have a window. We can uh, we can do nice color. So let's go to color picker. My bad. So let's pick a nice color. Yeah, this is nice. Then we are gonna do. I need, okay. I can take these values 25, and what I'm gonna do is uh, I'm gonna take decimal 25 divided by 255. So what the heck? Wait, I have to do standard 25 divided by 255. Yeah, so I'll be taking that, putting this here, 51, 51 divided by 255, which is zero point 0.2. So 0.2, 66 divided by 255, which is 0.25. And now we have set this color, and now we get this nice color, right? So this is our window. We are drawing, we are clearing our screen, and we can also check if we do this, it clears our whole screen, right? Unlike earlier version. What is this? Yeah, we can also do full screen, we can do back, we can move our screen. Yeah, so that's it. What I'm gonna do now is hit status, uh, window setup window, and OpenGL context. Let's go. Yeah, nice. Okay, that's it. Next would be, we have a couple of things to do. Uh, we'll be creating a renderer next time, but also before that, we will be creating platform independent memory, right? So one more thing that we will do, which will go into the detail more. Yeah, let's not do right now, we will do it later. Okay, so yep, I'm gonna end the stream. Bye bye.